Welcome back to the deep dive. We have a very interesting experiment for you today. Usually we take a stack of articles or some heavy technical guide
Mm.
and we synthesize it. We act as the narrators, telling you what the text says.
Right. Normally, we're the ones just condensing all that information for you.
Exactly. But today,
Hmm.
today is different. The source material we have is the Power BI Master Interview Guide. It's this massive, comprehensive breakdown of everything from interface basics to enterprise architecture.
Mm-hmm.
And we realized that simply reading you the definitions of, say, row-level security or star schema
Mm-hmm.
would be, well, let's be honest, it would be a cure for insomnia.
It would be incredibly dry. And honestly, it wouldn't even be that helpful because knowing the dictionary definition is so different from knowing how to use it in a high-pressure situation.
Precisely.
Yeah.
So we're shifting gears. We're going to role play. For the next 20 minutes or so, I'm going to be the hiring manager. I have a senior business intelligence role open. It pays well. The stakes are high. And I need someone who actually knows what they're doing.
And I suppose I'm in the hot seat.
You are the candidate. But here's the twist for you, the listener. We aren't just trying to, get the job. As we go through these questions, we'll break character just a little to explain why these answers matter to your actual work. We want to take you from a rookie understanding to an architect's mindset.
I love it. I've got my imaginary suit on. Let's do this.
Right. Step into my office, have a seat.
Thanks for seeing me.
Let's start with the elevator pitch. I see Power BI on resumes every single day. It's become a buzzword. But if we strip away all the marketing fluff, what actually is Power BI? And don't just tell me it's a visualization tool.
That's the trap, isn't it? Most people think it's just Excel on steroids or a chart maker. But if I'm strictly answering as an architect, Power BI is a business analytics ecosystem. It's not one app. It is a collection of software services, apps, and connectors that all work together to turn unrelated sources of data into coherent, visually immersive, and interactive insights.
Okay, ecosystem is a big word. Break that down for me. What are the moving parts that make this up?
Well, you have to look at the workflow to really understand the parts. It usually starts in the kitchen, so to speak. That's Power BI Desktop.
Right.
It's a free Windows application. That is where all the authoring happens. You connect to data, you mash it up, you build your models, and you create the visuals. It's the developer's sandbox.
So that's where the heavy lifting happens.
Exactly. But the end user, the CEO or the sales manager, they usually never even see the desktop app. Once the meal is cooked, you serve it in the Power BI service.
The service, okay.
That's the SaaS software as a service cloud platform. That's the dining room. It's where you handle distribution, security, alerts, all the collaboration stuff. And then acting as the waiter, you have the mobile app for consuming that data on the go.
Okay, that's a solid high-level view. But I want to dig into a specific pain point I have with my current team. I asked for a dashboard, and they send me this 20-page report. I ask for a report, they send me a single chart. In the Power BI world, are report and dashboard synonyms?
Absolutely not. And that confusion causes so many project failures because the expectations are just completely mismatched.
So set the record straight for me. What is the technical difference?
A report is what you build in Power BI Desktop. It's a multi-page, deep dive experience. It's highly interactive.
So you can click around.
Oh, yeah. You can slice, dice, drill down, cross-filter, and it's based on a single data set. Think of the report as the full newspaper. It has the sports section, the finance section. All the details are there. You go there when you need to understand why something happened.
And the dashboard.
A dashboard is exclusive to the cloud service. You can't even build one in the desktop app. It is a single-page canvas, just one screen, no scrolling ideally, that acts as a landing page. It uses these things called tiles.
Kyle's right.
You take the most important number from report A, a critical chart from report B, and a map from report C, and you pin them all to one dashboard.
So a dashboard can pull from multiple different data sets.
Exactly. That is its superpower. It's the executive morning briefing. It's just the headlines. If you see a number on the dashboard that looks weird, you click it, and then it takes you into the detailed report for the real analysis.
That's a crucial distinction. Dashboards are for monitoring. Reports are for analysis. I like that.
Precisely. If you are scrolling, it's a report. If it's a quick glance, it's a dashboard.
Okay, let's talk data. Before we can visualize anything, we had to get the data out of our systems. I've got SQL servers, Excel files, web APIs. When you connect Power BI to these, what's the strategy? Do we just plug it in and hope for the best?
This is maybe the first major architectural decision you make, and you can't really undo it easily later without rebuilding things. You are generally choosing between two primary modes, import mode and direct query.
Walk me through import mode first. Why is it usually the default?
Import mode is the default, and honestly, it should be your choice 90% of the time. You are literally taking a snapshot of the data from your source and loading it into Power BI's internal memory. It sits in a cache.
Why do we want to copy? Why not just read the original?
Speed, pure and simple speed. Because the data is sitting right there in memory, when a user clicks a button, the response is instant. The Power BI engine, it's called Vertipoc, is incredibly optimized for this. It compresses the data and makes it lightning fast.
But there's a catch, isn't there?
The catch is latent data. Since it's a snapshot, it's only as fresh as your last refresh. If you refresh at 8:00 a.m. and you make a sale at 8:05 a.m., you won't see it until the next scheduled refresh. For most businesses, that's fine.
But what if I'm a stock trader or a logistics manager monitoring trucks in real time?
But import is useless to you. You need direct query. In that mode, Power BI holds no data. It just holds the metadata, the names of tables and columns. When a user opens a report or clicks a slicer, Power BI actually writes a SQL query on the fly, sends it to your database, waits for an answer, and then sends it back.
So it's always perfectly live.
It's live, but it can be sluggish. You are completely at the mercy of your database's performance. Every single click is a round-trip ticket over the network. So generally, unless you have a legal requirement for real-time data, or the data set is just too massive to fit in memory, you stick to import.
There's a third one, though, isn't there? For when I already have a massive enterprise model.
Right, live connection. That's if you have, say, a SQL Server Analysis Services model or a certified Power BI data set already published, you just connect to it. You don't model, you don't transform, you just visualize. It's perfect for self-service BI, where you don't want junior analysts messing with the core definitions of gross profit.
All right. You've passed the basics. You know the landscape. Now I want to see if you can actually build something that doesn't break. Let's move to the intermediate round.
I'm ready.
I'm handing you a folder. It's messy. I've got a dump of sales transactions, a customer list in a CSV, a product catalog in Excel. A rookie would just drag them all in and try to link them up spaghetti style. What do?
I ignore the visualization tab completely. I go straight to the modeling view and I build a star schema.
Why? Why is everyone in this industry so obsessed with the star schema? Why can't I just make one big mega table with everything in it, like a giant Excel sheet?
You can, and for very small data sets, it might even work. But flat files or megatables are a nightmare for two reasons: size and complexity. Imagine you have 10 million sales rows. If you put the customer name and their address on every single one of those rows...
Oh, you're just repeating the same text over and over.
Exactly. You're storing John Smith 10,000 times if he's a good customer. That just bloats your model and kills your RAM.
So the star schema fixes that.
Yes. It's all about organizing data into two buckets: facts and dimensions.
Define those for me.
Fact tables are your verbs. They are the events. Sales, returns, logins. They're long and narrow, lots of numbers, lots of rows, but very few text columns. They just have IDs.
And dimensions.
Dimension tables are your nouns: who, what, where, when. Customers, products, locations, dates. These are short and wide. They hold all the descriptive text.
So in the star schema, the fact table is in the middle, surrounded by the dimensions.
Exactly. It looks like a star. The fact table just has a customer ID. That ID links to the customer dimension. So John Smith and his address are stored only once. It's cleaner, it compresses better, and most importantly, Power BI is engineered to expect this. If you don't use a star schema, your DAX formulas are going to become incredibly complex and buggy. You'll be fighting the tool.
Speaking of DAX, that's usually where people hit a wall.
Yeah.
I want to test your judgment here. I need to create a new data point, let's say profit margin. I can create a calculated column, or I can create a measure. Which one do I choose and why?
This is the classic Excel user trap. Coming from Excel, you want to see the number right there in the grid, so you add a calculated column. But in Power BI, that's usually a mistake. A calculated column is hard-coded into the table. It calculates row by row during the data refresh and is stored physically on the disk. It eats up RAM. If you have a billion rows, you just added a billion calculations that sit there taking up space, even if no one ever looks at them.
And a measure.
A measure is a phantom. It doesn't exist physically. It's just a set of instructions, a formula. It sits there waiting. Only when a user drags that measure onto a chart or filters by 2024 does the CPU wake up, run the math for that specific context, and give you the number. It's totally dynamic.
So it's the rule of thumb.
If you are doing math sums, averages, ratios, percentages, use a measure, always.
Is there ever time to use a calculated column?
Yes, if you need to filter or slice by the result, for example, if you want to group customers into gold, silver, and bronze based on their spend, and you want a slicer on the page for that, that needs to be a column. You can't put a measure in a slicer.
Good distinction. Now let's get into the weeds. The scary part of DAX, context. If you don't understand context, you're just guessing. Explain the difference between row context and filter context like I'm 5 years old.
Okay, imagine you are standing in a dark warehouse with a flashlight.
I'm listening.
Row context is the flashlight. You are pointing it at one specific box, one row of data. You can see the price in this box and the quantity in this box. You can multiply them. But you can't see anything else in the room. You don't know the total sales. You don't know the average. You only know this row. That's row context. It's tunnel vision.
And it's used in calculated columns.
Right. And filter context. Filter context is the room itself. It's the environment. When a user selects year in 2023 and region north, that narrows the room down. It hides all the boxes that don't match. The total sales measure then asks, okay, what boxes are visible right now? It sees the filters, grabs all the visible rows, and sums them up.
So row context is for iterating line by line, and filter context is for aggregating the big picture.
Exactly. And the magic, the real power, comes when you learn to manipulate that context using the calculate function.
The most important function in DAX.
Hands down. Calculate lets you say, I know the user has filtered for 2023, but I want you to ignore that filter and give me all years. That's how you do percent of total. You take the current slice and divide it by the all slice. You are effectively rewriting the rules of the room, the filter context, on the fly.
Let's apply that to time intelligence. I want to compare this month's sales to the same month last year. Easy, right?
Easy if you follow the rules. Power BI has functions like same period last year or total ETD, but they have a kryptonite.
Which is?
Gaps in your data. If you are relying on the date column in your sales table, you're in trouble. What if you didn't sell anything on January 1st? That date just doesn't exist in your sales table. The time intelligence functions will get confused and give you wrong answers.
So what is the mandatory fix?
You must create a dedicated date table, sometimes called a calendar table. It must have every single date, consecutively from the beginning of your history to the end. No gaps. You mark it as a date table, you link your sales data to it. That is the only way to safely do time travel in DAX. It gives the engine a continuous timeline to navigate.
Okay, you're nailing the development side. But this role is for an architect. I need someone who thinks about scale, performance, security. Welcome to the advanced round.
Let's get technical.
I have a report. It's beautiful. But the refresh fails constantly, or it takes 3 hours. I'm looking at the Power Query steps. What is the very first concept you check to speed up that data load?
I'm looking for query folding.
That sounds like laundry. Define it.
Think of Power BI as a manager and your SQL database as the worker. The database is incredibly powerful at crunching numbers. Power BI can do it, but it's slower. Query folding is the ability of Power Query to translate your steps, filtering, grouping, sorting into a native SQL statement, and send that to the database to execute.
So you want the source to do the work.
Exactly. You want to send a tiny request and get back a tiny package of results.
What happens if query folding breaks?
That's the disaster scenario. If you write a step that SQL doesn't understand, some complex M-language logic Power BI says, okay, the database can't help me anymore. It then has to download the entire raw table, millions of rows over the network, and then filter it locally.
So instead of asking for just the red cars, it downloads 10 million cars and then checks each one to see if it's red.
Precisely. That's why your refresh takes 3 hours. You broke the folding. A good architect checks the native query option to make sure folding is happening as long as possible.
Okay, the data is loaded. But now the user is complaining. They click a slicer, and they get that spinning wheel for 6 seconds. How do you debug a slow report?
I'm not guessing. I'm opening the performance analyzer.
This is a built-in tool.
Yes, right in the View tab. You start recording, you interact with your report, and it generates a log. It tells you exactly how many milliseconds each visual took to load. And crucially, it splits the time into DAX query and visual display.
What does that split tell you?
If visual display is high, you probably just have too many charts on the page. But if the DAX query is high, your math is inefficient.
And that brings us to the engine room. You mentioned Vertipack earlier. Why is some DAX slow?
You have to understand that the engine has two parts, the storage engine and the formula engine. The storage engine is multi-threaded and incredibly fast. It scans data. The formula engine is single-threaded and slower. It handles complex logic like if statements. A bad DAX measure forces the slow formula engine to do all the work. A good architect rewrites the DAX to push that workload to the fast storage engine.
Here is a scaling problem. We are a massive retailer. We have billions of transaction rows. It's too big to import into memory. But direct query is too slow for our executive dashboard. We are stuck. What do we do?
You use a composite model with aggregations. This is often called the holy grail feature of Power BI.
How does it work?
You create a small summarized table, say sales by date by store. You import that into memory. It's tiny and fast. Then you keep the billion-row detail table in direct query mode at the source.
And Power BI is smart enough to switch between them.
Yes. It's seamless to the user. When the executive looks at the total sales chart, Power BI hits the fast import table. Instant response. But if they right-click and drill down to see a specific transaction,
It goes to the source.
it automatically switches tracks and sends a direct query to the source for that one detail. So you get the speed of import for 99% of queries and the depth of direct query when you need it. You combine that with incremental refresh, and you can handle almost any scale.
Final question. This is a big one. Governance. I have a sales manager in France. When she logs in, she must only see France's data. If she sees the German numbers, we get sued. How do we handle this?
You need row-level security, or RLS.
Walk me through the setup.
In Power BI Desktop, you go to Manage Roles. You create a role, let's call it Country Filter. You write a DAX expression on the data table, something like Country France's, but that's static.
Right. I don't want to hard code names. I want it automated.
Then you use Dynamic RLS. You have a table in your model that maps email addresses to countries. Then you use the DAX function user principal name.
And what does that do?
It returns the email address of the person currently logged into the report. So when the report loads, it asks, who is looking at me?
So when the French manager logs in,
Power BI sees Marie at company.com. It looks up her email in your permission table, sees she's mapped to France, and then it instantly filters every single chart on the report to show only France. She doesn't even know the German data exists. It's completely invisible to her. One report serving thousands of users, each seeing their own personalized slice of reality.
I think you've got the job.
I should hope so. When do I start?
But seriously, that was a fantastic walkthrough. What I liked, and what I hope our listeners picked up on, is that you didn't just memorize the buttons. You understood the consequences of the buttons.
That's the key takeaway here. Power BI is deceptive. It looks easy because you can drag and drop a chart in 5 minutes, but to build a system that is accurate, secure, and fast, that requires an engineering mindset.
So for the listener who is prepping for this kind of interview or just trying to fix their broken report, what's the final piece of advice?
Don't obsess over memorizing every DAX function. You can Google syntax, focus on the architecture, understand the star schema, understand context, understand way the data lives and how it moves. If you understand the why, the how becomes easy.
Focus on the engine, not the paint job.
Exactly.
That's a wrap for this deep dive simulation. We hope you feel a little more ready to tackle that next data challenge.
Thanks for having me in the hot seat.
See you next time on The Deep Dive.